Hello, Kanishka.
Good evening, sir.
Good evening, Kanishka. Did you see those videos, earlier videos?
Yes, not now, sir. Only a little bit I watched. I had
Hmm.
some work.
Yeah,
Mm,
okay. Acha,
all
I'm going to
again
start.
tomorrow.
I
Yes, sir.
don't know, other students are absent, but we'll be continuing. Dynamics
Okay.
of fluid. Dynamics of fluid, I'll teach you. It's actually everything is new, so you should not be having any problem. It's not related to the previous part. Okay. Now, in the dynamics of fluid, dynamics of fluid means motion of fluid. Dynamics of fluids means fluid in motion. And when a fluid is in motion, the fluid in motion is of three different types. One is streamline flow, other is transition, other is transition flow, third one is turbulent flow. What we mean by this, just understand. First, we'll be studying about the streamline motion. What's the difference between these three? Streamline means orderly flow. When the flow is in the form of layers. Fluid actually flows in the form of layers, like this, one above the other, and or any fluid. If you want to find out the velocity at any point, you just draw the tangent. You will be able to get the velocity at that point. Okay, this streamline flow. Then the third type is turbulent flow. Turbulent flow is total disorder. It's turbulent flow, total disorder, and it will be like, means the particle will be moving randomly. The water will be moving randomly, no particular order. Total disorder. And in between them is the transition stage, transition flow. What is this transition flow? It's somewhat laminar and somewhat transition. Means it's that stage when the flow is changing from the laminar or orderly flow to the turbulent flow totally. It's like this. These arrows represents the different order. Means the ones it was moving like this, and then it has changed its order in middle. That's called transition flow. Now, in physics, in fluid mechanics, how do we actually define? How do we know whether a flow is transition or whether a flow is turbulent flow or the streamline flow? Using a number which is known as Reynolds number. This is represented by Re. How it is defined? It decides whether a flow is laminar or turbulent. That's all. The value of this Re is rho V d divided by eta. What is rho? Rho is the density of fluid. What is V? Velocity of fluid. What is eta? It's the coefficient of viscosity. See, I have not taught you by now what is the viscosity, because till now when we have studied about fluids, everywhere we have neglected the viscosity. Viscosity is like friction. Viscosity is a friction to the fluid, like we have the friction in Newton's laws in daily motion, like that. Here the friction in the fluids is known as the viscosity. What is d? Diameter means cross-sectional diameter. I'll draw it and show you. Suppose there is a pipe from which the fluid is flowing. So this area, this is the velocity. So this area is known as the cross-section area. Correct? And the diameter we are talking about is this one. This diameter. Now Aripriya will say, sir, I forgot.
Sorry, sir, for joining it.
What happened? You slept?
I forgot I was reading.
You are reading? Oh. Till now, see, I covered the theoretical part only somewhat. The dynamics of fluid I have started. Dynamics of fluid is of three types: streamline, transition, turbulent. Streamline means orderly flow of fluid. The flow of fluid actually takes place in the form of layers like this. Transition is when the orderly fluid flow is actually converting to the turbulent flow, means totally disorderly manner. The flow becoming totally disorderly. That flow in between stage of the middle stage between the streamline flow and the turbulent flow is known as transition flow. Means the flow is about to change. It's in the middle stage. It has started changing from streamline to the turbulent. Turbulent is total disorder. Streamline is total order. And in between between the stages, transition flow. Now, how do we know in physics, in fluid mechanics, whether a flow is streamline, turbulent, or transition? We decide according to the Reynolds number. What is Reynolds number? Reynolds number is rho into V into d by eta, where rho is the density of fluid, V is the velocity of fluid, eta is the coefficient of viscosity. What is viscosity? Viscosity is like a friction in real life. Friction in fluid is known as the viscosity. T is the cross-sectional diameter. This is how we actually define the Reynolds number. And there is particular value also. When Reynolds number value is less than 2000, it's the flow is known as laminar flow. And when this value is lying between 2000 and 3000, it is transition. And when it is greater than 3000, it will be turbulent. This is just the theoretical part. The interesting part will start now. In the fluid mechanics, means in the dynamics of fluid, you will study it in deep if you take in engineering. If suppose any one of you takes the mechanical engineering, there the fluid mechanics will be taught to you, but most of you will be taking IT or CSE, computer science. So when you study deep, you will study about the turbulent flow and all in more in your higher classes. Now, when we study about this one, mechanics of fluid, means dynamics of fluid, actually there are only two laws on the basis of which you will be solving every question, every concept of this dynamics of fluid. They are, one is equation of continuity, and second one is Bernoulli's theorem or Bernoulli's principle. Arey, what happened? Haripriya, till where did you hear the class?
Sir, I was there. I wasn't there when you wrote equation of continuity and Bernoulli's principle.
Okay. Then no problem. So only these two things you need to know to solve every problem of this, every good quality problem of this fluid mechanics of fluid. Every tough question will be based on these only. Only these two equations you'll be using. And because you're in class 11, I'll be teaching you I will be telling you the derivation of these also. But if we talk about JEE mains only the expression is enough. In the equation of continuity is A1, it's rho 1, A1 V1 is equal to rho 2 A2 V2, where it's for compressible fluid. Compressible fluid means the fluid which can be compressed, which has different density, where density is not constant. But this is not in your syllabus. In your syllabus, only non-compressible fluids are there. Those kinds of fluids for which density is supposed to be constant everywhere. So for those types of fluids, A1 V1 is equal to A2 V2. And now you must be wondering, sir, what is A1 V1 and what is A2 V2? That I'll teach you. Also, I'll tell you the derivation also, because it may be asked in your class 11. This is equation of continuity. Where what is A1? If I have drawn this kind of cross section, say the area, cross section area is A1. V1, V2 are the velocities. Here velocity is V1, here velocity is V2. Area is A2 here. This is what? This is a pipe whose area is decreasing, like that. Like that you have to see. A1 into
non-compressible fluids are ideal fluids.
they're ideal fluids. Compressible fluids are non-ideal. A1 into area, V1 into is the velocity. Now see, I'll tell you the derivation of this also. Actually, it works on the principle the rate of flow of the fluid is same. How the equation of continuity works? Based on rate of flow is constant. What is rate of flow now? Rate of flow is volume of liquid flowing per second. Okay. Now what they say from this, if suppose this much amount of liquid means area and x1 amount of liquid is flowing in delta t time, then from here x2 amount of this much amount of liquid should be flowing in delta t time, and these two, the amount of liquid flowing per second per delta t time from this and this will be same. It works on that principle. And now Q is what? Volume of liquid per second. If we talk about the first area, means from first area how much liquid is flowing per second, it will be what? A1 into x1 divided by delta t. Correct? And similarly, the amount of liquid which will be going out will be A2 into x2 divided by delta t, same time. Now when the flow, same amount of liquid which has entered, the same amount of liquid is flowing out, then x1 by delta t will be what? Velocity. So I can write this as a1 into velocity v1 is equal to a2 into velocity v2. That's why this equation of continuity comes. This is the explanation for equation of continuity. Why the equation of continuity arrives. A1 v1 is equal to a2 v2. And trust me, this will be very helpful for solving questions. Okay, this one is done. You understood this one? And when
Yes, sir.
you will be having doubts, sir, why will get density multiplied? Actually, it's the rate of flow is constant. It comes when actually this arrives from this rate of flow. Why we are doing rate of flow is constant? Because the original thing is mass of fluid should be constant. If we talk about the compressible fluid also, the mass is constant. The mass of the liquid which is coming inside should be equal to the mass which is going out from it. So density into volume per second, density into volume is the mass. So that's why we multiply density also there. From this mass of fluid which is coming inside is equal to mass going outside, arrives this volume of liquid rate of flow is equal to constant. This one. Actually, it is not. This derivation and this understanding is not important. The important thing is you know what is this equation of continuity, because in JE never they won't ask you this derivation, but for CBSE they may be asking you. Now coming to Bernoulli's principle. Wait. Hmm. Bernoulli's principle is also very interesting. Bernoulli's principle is actually based on work energy theorem. Let me draw it. The statement is, if I draw a pipe like this, suppose this is a reference line, it's at a height h1, this is at a height h2. Suppose the area is a1, this area is a2, the velocity of fluid which is coming inside is v1, this is going outside is v2, and let's say I have shown this is open pipe, but let's not assume this is open. Let's think it is closed and the pressure here is P1. Let's assume here pressure is P1 and here the pressure is P2, say. Now according to their statement, Bernoulli's principle, what they say, P plus half rho V square plus rho GH is equal to constant at every point in a fluid. What's the meaning of this? Meaning is, we can write P1 plus half rho V1 square plus rho GH1, means we have applied this Bernoulli's principle on the leftmost part of the pipe, is equal to P2 plus half rho V2 square plus rho GH2. This is the statement. Now, how do we get this one? Proof is, again, this much statement is okay for you if you talk about JEE Main, but for class 11 they may ask you the derivation. That's why I'm teaching you the derivation part also. Now the proof comes from work energy theorem, or you can say law of conservation of energy. What this work energy theorem says, total work done, this statement you already know, total work done is equal to change in kinetic energy, final kinetic energy minus initial kinetic energy, right? This you already know. Now suppose C, because the pressure is acting on both the points P1, P2, that means what? Forces are there at this point also, at this point also. So if we calculate the work done due to this pressure force, how it will be? If we say from this part also delta V amount of liquid is going, and from this part also delta V amount of liquid is coming out. So one work will be work done by the force F dot delta x, which I can write as F by A into delta x into A. A delta x is delta V, volume. So I can write the work done as P delta V at every point. So here the work done at left point is P1 delta V. From right point is P2 delta V, so I can minus them. This is one work done. Also, there is work done by mg also. Mg is acting downwards. It has moved from height h1 to h2. So, but its work done will be negative. So, because mg will be acting downwards, h1 to h2, the fluid is going up. So, it will be negative, which I can write as minus mg into h2 minus h1. This will be equal to half into m into v2 square minus half into m into v1 square. Correct this one?
Yes, sir.
Okay, now mass I can write as density into volume, rho into delta V. Delta V volume we have considered, now density into volume is the mass. Let me write it. So it will be P1 minus P2 into delta V minus rho delta V into G into H2 minus H1 is equal to half V2 square minus V1 square into rho delta V. Delta V, I can cancel them out. So I'll get what? P1 plus rho G H1, half rho V1 square, I'll come bring this side, half rho V1 square is equal to half rho, okay, I'll write orderly. P2 plus rho G H2 plus half rho V2 square. See, it's proved now. Very easy one, not difficult one, but again, it's not necessary for your JEE main examination or JEE advanced examination. It's only necessary for your class level examination. I have calculated total work done. I have calculated this is work done due to the pressure force. This is work done due to mg and will be equal to change in kinetic energy. Clear? See, a very easy type of question on the basis of this, on the just understanding of this equation of continuity is the rate of flow. That means the amount of liquid flowing per second is same. How they frame the question, I'll give you one type of question. Just see this one. So why I say derivations are important. Try to see this one. The question is not difficult. It's easy only. But try to see. Are you getting the idea how to solve this one? It's very easy question.
So in this, we will use that concept in which the fluid that is going inside
Hmm?
the first tube will be equal to the fluid in the other two tubes.
Yes. The rate of flow is
Sir,
same
1
or
meter per second.
Hmm. That this concept I told you na, in the derivation. Volume of liquid flowing per second is constant. How much amount of fluid will enter, that much amount will go outside. Means the mass of fluid that has entered will be equal to total mass going outside. That one. So here what you will do, just apply in the initial A into V1 is equal to A into V2 plus 1.5 A into V. Cancel A. V1 is 3. This is 1.5 plus 1.5 V. 1.5 is equal to 1.5 V. So V will be equal to 1 meter per second. Good. Kanishka, you understood?
Yes, sir.
Okay. Now let's move on to the next part. This was actually the easier one. Just remember only these two equations, the equation of continuity, A1 V1 is equal to A2 V2. One is this one and the other is this one. Only these two you will be using to solve all your questions. Achha, now let me tell you more applications. Next is Torricelli's speed of efflux. This is also known as Torricelli's law. Again, they may ask you in the form of derivation, but you yourself will be solving it. Not difficult. Let me give you the diagram for this first. Mhm. Yes. Hmm. See, this is the diagram. Let me explain it to you first. What is this? This is a container in which is filled up to a height y2 from the bottom. There is a hole in the on this right side of this container at a height y1 from it. Difference between the y2 and y1 is h. It's given to you, and the liquid is flowing out of this hole with the velocity v1. What's our task? Our task is to find out this velocity v1 coming out of this hole, which is known as speed of efflux. And what's our assumption? Our assumption is this velocity. If I take this velocity v1, let's say v1 is approximately equal to 0. Why? because this is a very large container, the amount of liquid will be going down very slowly as compared to this part, because if we because we know that equation of continuity a1 v1 is equal to a2 v2, and we know a1 is a2. Let me write. So this should be v2 now. Because we know this a2 area is very large, it is very much greater than a1. So obviously this v2 should be very small. V2 should be very much less than v1, right? Correct? So we are not at all interested in finding v2. We are only concerned with finding out the value of v1. But how do we find? We actually, again, I have told you only two equations you have to use to solve every question of this. One equation is equation of continuity, you already know. A1 v1 is equal to a2 v2. Correct? Other is Bernoulli's theorem. Can you give me the equation of Bernoulli's theorem? How I'll write the Bernoulli's theorem equation here between point 2 and 1.
PA plus half rho V, half rho V1 square plus rho GH.
Rho GH or Y1
Y1
is equal to P2 plus
plus half
rho V2 square plus rho GY2. Correct? This is our Bernoulli's theorem. Now what is there? So this is PA, na? You understand what is this PA? PA is atmospheric pressure. Because it is open to atmosphere, na? That's why. Whenever something is open to atmosphere, the pressure is PA there. Now, what's our task? To find out the velocity v1. I can further simplify this one, because P2 is equal to P they have given. PA minus P, P2. So let me write here only. PA minus P is equal to half rho V2 square minus half rho V1 square plus rho G Y2 minus Y1 is H. So I'm writing directly H, rho GH. Now we need to find out this. So I'll write PA minus P into 2 . No. One more thing I'll do. 2 into PA minus P minus rho GH. Now correct. Is equal to rho into V2 square minus V1 square. Now I'll make use of equation of continuity to find out V1. I can write V2 as A1 V1 by A2. A1 by A2 whole square minus 1. Okay. Correct?
Yes, sir.
So now what relation I am getting? 2 into PA minus P minus rho GH divided by rho into A1 by A2 whole square minus 1 whole root. This is equal to V1. This is actually very complex one I have written, but things actually simplify. I'll tell you why. How they simplify. This is the actual expression that we should have. And V2 also you can find, but don't worry. V2 will be equal to A1 V1 by A2. Just multiply A1 by A2 to this, you'll get the answer. But in reality, we do not use this expression. Why? We make some approximation. What approximation? I said A2 is very much greater than A1. This is first one. So in the denominator, this A1 by A2 will approximately become equal to 0. Right? One thing. Other thing is, this container is open. You're able to see this one, the top point. This container is actually open, made open. So when it is open, P2 will become equal to atmospheric pressure. Okay? Or P2 is equal to P becomes atmospheric pressure. So this will cancel out. Now using these two approximations, what answer you get? V1 is equal to PAP will be cancelling 2 into minus rho GH divided by minus rho. This will cancel. So you will get root 2GH. So V1 is equal to root over 2GH you'll get. This value actually we use in the calculations, known as velocity of efflux. And when we use only this approximation, that A2 is very much greater than A1, in that case, the value of V1 is equal to root over 2GH minus 2GH plus 2 into P minus PA divided by rho. This is the expression when container is closed but A2 is very large as compared to A1. You understood? Haripriya,
Yes, sir.
you understood? Diva,
Yes.
this is actually important. The way I have solved this one is actually important. At least you should remember this result and why did you get it. Okay, let me give you some question. Acha, take this one. Tell me how you will solve this. If you have understood this concept, tell me how you will solve it, because there are two fluids. Hmm. Can you solve this question? Acha, just in this case, first just tell me who is out. Shiva, Haripriya, Kanishka is out. Just tell me what velocity you will get here.
The root 2gh.
No. See, what you have to
We
do
should
here.
also consider the density of the above
Above one.
liquid.
See, how, see, because you know you can apply this Bernoulli's theorem only in the same liquid. So you will be the 2 points that you will be considering will be one point will be this and the other point will be this. One this, other this. So here that pressure is P naught, atmospheric pressure, here also P naught. But what will be the pressure at 1? You know this is H. So P1, I can safely write P1 is equal to P naught plus rho g H. Okay. Now A1 V1 is equal to A2 V2. I'm doing it descriptively, means I'm explaining you totally. And then P1 plus half into 2 rho into V1 square is plus 2 rho into G into 2H is equal to P naught, because outside pressure is P naught, plus half 2 rho into V2 square. Let's say this velocity is V2, this velocity is V1 here, plus 2 rho G H. Like this equation you will form. So I'll write P naught, P1 value, P naught plus rho GH, half 2 rho into V1 square plus 4 rho GH is equal to P naught plus half 2 rho into V2 square plus 2 rho GH. Here will be, you will get 3, so it will be 6. Rho, let me cancel. Rho. 6 GH is equal to 2 V2 square minus 2 V1 square. I should have cancelled them out. 3 GH is equal to V2 square minus V1 square. Now, because I say V1 is actually very less, V1 we have approximated to be 0 because its area is very large. So I can write V2 is equal to root 3GH. So the actual velocity that Diva you were saying was root 2GH is actually root 3GH. Or you can do it other way also. 3GH is equal to V1 you have to, V2 you have to find now. So V2 square into 1 minus A2 by A1 whole square. So V2 will be root 3GH 1 minus A2 by A1 whole square. But since A2 is very less than A1, you will neglect this part and you'll get V2 is equal to root 3GH. You can do either way, either left way or the right way. Understood, Diva?
Yes, sir.
So be very careful when that's why I given you different with density liquid. Now once you have found out the velocity here, after this is only kinematics. The range R means the from here to here, because the velocity is horizontal, that how much time it will take. T is equal to root 2h by g. H is equal to ut plus half a t square. Kinematics formula. And range will be equal to v2 into this time t. So R is equal to root 3gh into root 2h by g. So root 6h. R is equal to root 6h. This is the answer. Did you understand? Haripriya, Diva, Kanishka, how did I solve this?
Yes, sir.
After finding velocity, it's
Yes.
just kinematics. Okay, let's end it then.
Bye.
Bye bye.